right now we just wrote these programs using normal human language. Computers will not understand this language. They don't understand mathematics either, in terms of, yes, plain mathematics like this. They don't understand that. The only thing computers understand is either there's electricity or there's no electricity, isn't it? Right now, if you unplug your computer, okay, that's if it is plug and play, it will just go off because there's no electricity. And that's what we do when we press the power button. And the power button, you can see it usually has this symbol. Yes, because it is just the composition of this 0 and 1, which says this button will put the computer in the one state, which is on. So on, or in the 0 state, which is off. So that's what the computer understands. The same way, if we go deep inside the CPU and where it does all these calculations, it's about turning on some switch, okay, like the switch on your wall, which has some wires like this. So let's say there's wire here, and then it connects to something. So let's say some light bulb here. I wouldn't want to go deep into the electronics part, so I wanted to stay light here. So another circuit here with another light bulb. I know you have many of them in the room. So then you have another switch. Okay, so anytime the CPU does any calculation, it's like it's closing or opening switches so that some light will go on, will go, yes, on or off, or on or off. So it creates this combination of switches, so many of them, many of the switches. And these switches are handled by an electronic component called the transistor. I don't know if you know of it. Okay, don't worry. That's the electronics part. We don't want to bother right now. We'll have other courses that will discuss electronics. But the core concept I want you to have to understand at this point is that these transistors, they behave like switches, just like the switch you have on your wall to turn on light and off. So the CPU has them in billions or even trillions sometimes. So imagine having, let's say, 10 switches in your room. You can imagine how difficult it is when they ask you go and on the light in the evening. It is going to be tedious. But the CPU has the capacity of turning on a switch, turning on and off the switches, like maybe some millions of times per second. So even it means if you had 1 million switches in the whole Accra, a CPU can turn them on in less than a second, or turn them off in less than a second. So now let's assume whenever the CPU turns the lights on, it tells us it is night, and whenever it turns them off, it tells us it is day, right? So we just did what we call interpretation. So we interpreted these signals, which is on or off, into something meaningful, which is it is daytime or it is night time. Okay, so the same thing the computer does. Whenever the switch is off, which is the 0 state, we give it a meaning. Whenever the switch is, okay, this is the on state, and whenever the switch goes off, so the switch is on here, we give it a meaning. Whenever the switch goes off, we give it a meaning as well. Okay, so that's why sometimes you hear people say that the CPU understands binary. So the idea is that the CPU knows whether to turn a switch on or to turn a switch off. And when you have so many switches, to turn on and off. So it means you might end up having, let's say if we were to represent these switches with their state, so we can have maybe the first switch is off, the second switch is on, the second switch is on, the third switch is on as well. So you end up having some kind of number of 0, 1, 1. Okay.
Yes.
Or it can be like, okay, the first one is on, the second one is off, and the third one is on. Or you can have the first one on, the second one off, and the third one off as well. Or you can have the first one on, the second one on, the third one on. Or even have 3 of them off. So you see, each one of these series of 1 and 0s is what we call binary numbers. So this is a binary number, this is a binary number, this is a binary number. So within the CPU, it is this kind of things: a switch being off, a switch being on, a switch being on, switch being on, off, on, off, off, on, off, off, off. So it's kind of this, and that's why we are saying the computers understands only binary language. It only knows binary language. So it means whenever we ask it to do 5 plus 5, it must find a way to give a meaning to this 5 in terms of switches. So it must find a state of switches and decide to say, okay, this 5 will be represented by the first switch being on, the second and third switches being off. You get the idea? So the CPU will find a way to say, okay, this 5, it has to be converted into 100, and the next 5 will be converted into 100. So the next thing the CPU is going to see, okay, the first number says that the first switch is on, the second one is off, and so on. And then the next number says it is on and off as well. So we want to find out what is the final state. The final state is that, okay, all the first 4 lights are off, right? I'm just saying it in terms of just plain language, okay? All the 4 first lights are off, and then the 4 last lights are off, and then the first 2 lights are on, right? So that could be the final result the computer will bring out. Then it will know that, oh no, human beings don't understand this kind of representation in terms of switches. Let me also find an interpretation to it in their own understanding. Then it will move it and then say, oh, it is equals to 10. Are you getting the point? So there's a translation from a human understanding language to a computer understanding language, and then from the computer understanding language to a human understanding language. Okay? So this is called translation and interpretation. So we do the translation here, we translate, or transformation, and then here we do an interpretation. So we interpret these numbers. Interpretation. Please be taking notes, okay? Use your journal very well. Note every single thing.
Okay.
Note every single thing that will come in mind. It will help one day. Although I want it to be helpful today, but it will help one day. So this is to bring us to the point that since the computer understands only this this language of switches and so on, so how do we program it? It means anytime we want to tell it, okay, tomorrow, just on the, we want to give it a program that looks like this. So let's say we have a program that looks like 1 0 0 1 1. So we are telling it the first light, turn it on, right? Second light, turn it off. Third light, turn it off. Fourth light and fifth light, turn them on. So this is a program. We could write it very well and give it to the computer. we'll discuss about where we write it and where we give it to the computer later on. So we could well write this and give it to the computer, and it will execute it easily without any problem. So if you are able to find the place where to write it and give it to the computer, it will write it for you. It will execute it and you will see something. But imagine we are dealing with a CPU, or that can run a CPU, let's take it that way, that can understand, let's say 1, 2, 3, 4, 5 switches. And in the case we are dealing with, let's say 10, 20, 60 switches. You see, writing 60 numbers in a particular order like this can be challenging, right? It can be difficult to write and tell the computer, go and do this program. So this first language, which is the binary language, human beings were finding it very difficult to use it and talk to computers. It is very challenging. Okay, so what we did was we found a way of writing it in an intermediate human-friendly language. Okay, so which will be like, okay, on, or let's say we use the term 10 on, and then when we say 10 on, we'll give it a certain number, let's say 20. Okay, and then we'll be like 10 off, 30 and 33, and then 11. Then we'll be like blink. So maybe we have these lights that can blink. Okay, blink 6, 1 and 10, and then let's say 15. So what we are trying to say here is, okay, if we give the computer 10 on 20, it will turn on the 20th light. Isn't that easier and better?
Yes.
Good. Then we say 10 off 33 and 11. So we just write 33 space 11. It will know that, oh, they are asking me to turn off the 33rd line and then the 11th light. That's quite easy and cool than me writing these binary numbers. Then we are like, again, blink 61 and 10 and 11. That's quite interesting, right? So yes, this intermediate language was named assembly. Although this is not the true assembly, but that's the idea. So it was named assembly language. So as you are learning programming, even as we are speaking, you can Google it and see. This my Y is crazy. So assembly. It was named assembly. So assembly is a way of turning the binary numbers into something a bit understandable for human beings to write. And whenever we write the assembly, then we need something in between to convert it into the binary, because after all, we are going to use the binary, we are going to send the binary form to the computer. The computer will definitely not understand the assembly. So we convert it into the binary form. That process of conversion is called compilation. Okay, or interpretation.
So from assembly to binary is
compilation, yes.
Okay.
Or interpretation. Interpretation. Okay, and right here you could see the computer also does the interpretation from the binary form to a human understandable form. Like the final results must be interpreted into something human beings can understand. Okay, so when we compile as the assembly, when we write our programs in assembly, then we compile it, or we do the interpretation depending on the tools we are using, and then we get the binary form. Then we submit that binary form to the computer. Then this will tell the computer which switches to turn on or off. Right? But as time goes, it happened that assembly tools started to become very tedious and difficult to handle because the needs of programs are becoming more complex. Programs are becoming complex, huge, and it becoming, imagine you are having 10 on, so many of them, and you have to align many numbers, let's say some 100 numbers in front to be able to indicate the switches and so on. And sometimes you might want the computer to keep on doing this repetitively. So for example, in our case, if the program runs, it will turn on the light 20, turn off the light 30, and 33, and then 11, and blink 61, 10, and 15, and then it will stop there. So what if we wanted to be doing that every single given hour, let's say every morning or every evening or every afternoon? So how do we tell that? So we might need to use something and say return or repeat. You see, we might need something. So it will keep on adding many of these, and by the time we realize the assembly has become so difficult to handle and hard for human being. It's not bad, but it is just harder for human being again. Okay, so that's what happened. Assembly is still used widely. So many people program in it and use it, and there are some situations where you cannot dodge assembly. Mostly when you are doing system development, like you are building operating systems and so on, it will be difficult for you to avoid assembly. Okay, so that's what pushed people to think of another layer of abstraction. Remember last time I told you about abstractions. It is about adding or simplifying something which was already simplified. So it's like another level of simplification. Okay, if possible, to another level of complication. Are you with me?
Yeah.
Okay, so we decided that, oh, this looks a bit difficult. What we want to do is, okay, we want a simpler way of saying this same thing. Okay, we will be like, okay, how am I going to invent this language now? So I will be like echo. No, I will use the word print, for example. I don't know why my mouse is doing this. So I'll be like print, and then I'll indicate, let's say 20. Okay, and then I'll be like if evening, or no, if morning, sorry. So if morning, I missed some R here. I need something to help me write faster on the screen. So if morning, then print, okay, print out. So let me use it this way. Print out, because we are going to use a different function, which is the 10 off 33 and 11. So you see, this one sounds a little bit human friendly, and the words we use kind of mean what we want to do. Okay, are you with me?
Yes, please.
Okay, are you tired?
No, please.
Are you sure?
Mm.
Okay, So this brought us to what we call high-level languages. Okay, because these languages now, this small thing we just did, can also be interpreted into assembly. Okay, so we can also transform it, compile it into assembly, then from assembly to binary. So we keep on layering and layering and layering and layering and so all this. So in our case, nowadays, what you are learning, you are going to meet these high-level programming languages. High-level programming languages. So some of them you will meet are like the C programming language, Python programming language, and so on. Now, the interpretation of these languages into assembly here does not always happen like that in reality. When we write Python, we don't always have to compile Python into assembly before the computer runs it. Okay, some of these high-level programming languages can be directly compiled into the binary version of it. Okay, so depending on how the compiler is written, that's what determines how the compilation process happens. But the key point for us here is to understand how things moved from the binary to we having high-level programming languages. And today, when you start learning these high-level programming languages, you will see that people will be like, oh, this language is compiled and this one is interpreted. Okay, so for example, when you write a C programming language, you will need to compile it before the computer executes it. But when you write a Python language, a Python program, it does interpret it. As soon you run it, and then while it runs, the computer does the compilation. So these kind of languages are called interpreted languages. Okay, you meet these terms often.
Okay.
Yes. So this is what brings us to our language we are going to study, which is Python. So we want to talk to computer, write programs, then we will need to know at least one programming language to do that. And in our case, we chose Python.